It's about the last problem from the d- um from the dilution section problem.
Right. Is it the one where you have iron and then it's hot and you're putting it in water and you're trying
Yeah, yeah. Can you help me out with that one?
I'm going to do a different one today in lecture so
Okay,
that y'all can still practice it and try to get that answer.
okay.
Okay, I am going to do one. Um, let me go ahead and make an announcement. Uh, I've created an activity number 7, and it will, for your class, it's going to open well, not immediately, like hold on, let me get this person in. It's going to open at around 10 a.m. today, and you'll have until Saturday at noon to do it. It's D2L. It's in the assignments folder. It says assignment number 7. It's 2 problems. One of them is a calorimetry problem, like I'm going to do today, and one is a Hess's law problem, which I'm going to do today. That is not a required activity. It's just one of the activities I'm giving. Remember, I'm going to take the best 5. The other announcement is I put on Chem 101, it's your test number 5, but it's the chapter 10 part only. It has 7 questions. It starts for this class. It's not going to start till Friday, right after your class, your lecture on Friday, and it closes on Monday, right before the class starts. You're given an hour, it's 7 problems. It's 20 points. It's going to be 20 points out of your 100 points for your test 5 grade. I'm trying to do this in steps so that you're not going to be overwhelmed with test 5. And here's my example. It's 7 problems. It told me that you should be able to do it in 30 minutes. I'm giving you an hour. I think only a couple of them are calculator problems, maybe 3, 3 or 4, but they're not that you just write the answer in the blank and the units already provided, but you have to be careful on one of them, and I'm going to point that out when I do my calorimetry problem. I'm going to try to remember on Friday to email this information. Okay, but are there any questions? So you've got 2 things going on after class. The first one is an activity number 7 that you'll have until Saturday. And then the second one is your 20-point chapter 10 part of your test number 5. We only have, after this week, we only have 2 more weeks before that final. And I still have to cover gas laws and some of chapter 12. So I'm trying to do this in steps. Are there any questions before I start my lecture? Oh, let me write a couple people that came in, sorry. Okay, I'm going to start. Now, some of this might be a repeat, but I think it'll be helpful. There are 2 sections, 2 main sections in chapter 10. One of them is called calorimetry, where it has a formula. I just translated from the formula to words. It's basically heat equal mass times specific heat times your change in temperature. If your mass is in grams and your temperature's in Celsius and your specific heat is a physical property, a combo unit, joules per gram degree Celsius, which does not limit your significant figures, these units will cancel and give you the joule. Now, just question to the class. Had I already covered this sheet?
Yeah.
Okay, well, it's fine. If we want specific heat, or if they give you specific heat in terms of calories per gram degree C, and you needed to convert it back to joules, there is a conversion. On your Chem 101, that conversion is provided. Or, you can use your notes, so it doesn't matter. Now, here is the straight plug and chug, and I'll do it quickly. If I give you an amount of a substance in grams, I provide the specific heat, and I'm simply wanting to take this substance, according to this problem, I want to go from 10 degrees all the way up to 75. So my temperature change is 65.0 because you're obeying the three significant figures. Heat equal mass times specific heat times your change in temperature. Now, here's something I want to point out. You solve for joules, and I got 6.80 times 10 to the fourth joules. I could rewrite that as 68.0 times 10 to the 3 joules, so that I can express it in kilojoules, because 10 to the 3 means 1,000. Now, this is why I'm pointing this out. On Chem 101, one of the questions is this straightforward, but the unit for the blank is kilojoules. See, so if you solved it in joules and you think, oh, I know my answer, and you type it all in, you've got the wrong amount because they want it in kilojoules. Am I making sense what I'm trying to say here? Perfect. Okay. If they wanted you to convert the joules to calories, this is how you would do it, using that conversion. This is your joule answer you just got. You would simply divide by the 4.184 so that the joules cancel, and that will give you calories. You could express this in kilocalories, the same way I just expressed the joule one. Okay, so you're just going to have to pay attention to the units. Now, Francois, this problem I'm getting ready to do for all of you. He asked a question at the very beginning. Oh, let me let this person in. Sorry. He asked the question at the very beginning about heat loss equal heat gain. So I'm going to do this one. Tell me, no, I didn't do this one. I created this one since your class Monday. Okay, let me read the problem, then I'll hold my sheet up. It says, determine the final temperature. When 136 grams of a hot piece of metal at 108 is added to 378 milliliters of water at a cooler temperature. Okay, first step. Milliliters of water is gram of water because the density of water is 1 gram per milliliter. I give you the two specific heats. So here's my problem. We're determining the final temperature. Basically, I'm taking something pretty hot and putting it in water that's cool. And I know the temperature can't go above 108. And I know the final temperature can't go below 23. I give you the specific heats. Do not worry if you don't have all these numbers copied, because this is how I want to teach you to do it. Draw yourself a line, okay? Write all the information of the hot stuff at the top. The mass of the metal, its specific heat, its hot temperature. Then at the very bottom, write all the information of the cool stuff. The mass of the water, which I converted, specific heat, the low temperature. You know your final temperature is somewhere here. Now, concept. This specific heat related to heat capacity is so much greater in value than this number. So my final temperature won't be here. It's going to be closer to the water temperature. Could y'all follow what I'm saying there? Because that's a concept question on Chem 101. Okay. Okay, we have a formula. The concept is heat lost by the hot must be picked up or gained by the cool. So for the word heat, I simply wrote my mass times specific heat times change in temperature. All of this side, the left side, is due to the metal, equal, same three words, mass times specific heat times temperature change, but the right side information is due to the water. Okay, do we understand this little concept here? This will help you to set up the problem. Now what I'm going to do, I plugged in my numbers. Oh, you know what? Let me say something about temperature change, because this is the algebra part. Your temperature change here for the metal is 108 degrees Celsius minus TF. You know you're going to end somewhere here, you just don't know the number. The temperature change over here for your water is TF minus 23. So it's high minus low is the top temperature change, high minus low, the right side temperature change. And now I've written my numbers in. Okay, I've written them in. So mass, metal, specific heat, metal, temperature change, metal, in parentheses. Mass, water, specific heat, water, temperature change, in parentheses. What I like doing to clean it up, to make it easier for me, is I like to cancel like units. I get rid of the gram, I get rid of the combo unit. Okay, then what I'm going to do is divide both sides. I like to divide both sides by the right side product here, and here's why. On the right side, it's just going to leave the TF minus 23. That's really simplifying the right side. So I have to figure out this number that I've got, I've got 136 times the specific heat, that product divided by whatever this is, 378 times 4.184. Well, that's the number I get. Okay, I get that number. I'm going to have to, it's called distribute. So here's my next sheet. I distributed, or I'm going to. So I'm going to say this tiny number times 108, I get my number. This tiny number times minus TF, or minus, I get my number, equal TF minus 23. Now, from this step down, you're just putting your Celsius on one side. By adding to both sides, it looks like I'm going to add the 23 to both sides. And then you put your TFs on one side. So I'm going to add this number to both sides. And my final step is I'm going to divide both sides by that 1.0, whatever it is, 1.0256. Now, I'm obeying two significant figures because of this. Now, what is that temperature? 25? What was the low temperature? Wasn't it 23? So it went, look, water started at 23. And we put that hot piece of metal in there, but because of the specific heat of water, it only went up to 25. Could y'all follow that? One part of your activity number 7 is a problem like this. Are we good? Everybody? Francois, did that help?
Yes, ma'am. Yes,
did that help?
Yes.
Okay. So when you go back to your homework, which did I bring it up here? That last problem that you were asking me, I think, didn't I already put the numerical answers on that whole practice?
Yes, ma'am.
You should get a temperature of 26.1 when you go back and try it now, okay?
Okay.
Okay. Any questions with calorimetry? Or, oh, you know what? On that first problem, it said how much heat needed. That joule number needed to be a positive value. If it had said, let me put that first problem back up and show you something, because there may be a sign question. Okay. On this first problem I did, which is a repeat, it said how much heat is needed, because I'm taking it from low to high. If this question had said how much heat is released when the water's cooled from 75 back down to 10, okay, then you would need a negative sign here. Did I go over that convention? I think I did last time. You need a negative sign if it's released. Okay, any questions before I do the new today? The new for today is called Hess's Law. Okay, we're going to start. Hess's Law, this is section 10.5 in your book, or I've emailed you guys the chapter 10 PowerPoint slides. Definitely look over the 10.4 slides and the 10.5 slides because they have additional examples. I created all these examples as different ones than the book, so that way you'd have more as a reference. Okay, the trick to Hess's Law. The concept is, and they use this analogy in the book, so I'm going to go ahead and do it. If you're on the first floor of a building and you need to get to the 6th floor, you could go, you push your button, 6, and you go. You could get to the 6th floor by going to the 2nd, and then maybe the 4th, and then maybe the 6th. So you could go in steps, but the end result is you still get to the 6th floor. This Hess's Law, you have an end result. It's called the goal reaction. And they're going to give you steps. They're going to give you 2, 3, 4 reactions, and you have to juggle the reactions around in such a way to cancel out your like species and get to the goal. Now, here are the rules. If you flip a reaction, you have to change the sign. They're going to give you delta H values. This is like heat of reaction values. You have to change the sign. If you multiply a reaction, say by 2 all across the board, you have to multiply the delta H by 2. Well, let's say you divide everything by 3. Then you have to divide the delta H by 3. So those are the 3 main rules. If you flip the reaction, and I'm going to do a couple of these. If you flip the reaction, change the sign. If you multiply or divide the reaction, then you have to do the same. Whatever you did to the reaction, you have to do it to that delta H. Then you have your steps. You add them all together, and you cancel anything that appears on either side of the arrow. So it's like a puzzle. That's all it is. Here's my first goal reaction. Let's see. Well, I want to hide this so it's not so busy. Okay, this is my goal reaction. I want to end with 3 hydrogens and what is that? Sorry, 2 ozones and make 3, is it water? Oh, hydrogen peroxides. That's my goal. Okay, what they give me the 2 starred in green. This was given. Okay, they give me this one. Let's just look at the top. They give me 2. It's a 2-step Hess's Law problem. I notice here that the hydrogen is on the left. Well, it's on the left here. So I'm going to keep the sign. I'm not flipping it. However, I notice a 3 there. I have to take this given reaction and multiply every one of those things by 3. If I multiply that reaction by 3, I have to multiply my number by 3. So I'm down to here where my fingers are. Could y'all follow what I did on that reaction? Yes? Yes or no?
Yes. Yes, ma'am.
Okay. Second reaction. I notice that it has 3 oxygens here, and the ozone is on the right. Oh, I've got a problem. My ozone needs to be on the left. So that tells me I have to flip. If I flip a reaction, which I flipped it here, you must change the sign. Okay, now here's what it looks like now. Oh, where'd it go? All right. So I've got my reaction here where I've multiplied everything by 3. I've got my flipped reaction, and look what I notice. Oxygen is on the left and it's on the right. So I cancel. I add the two together. I get my goal. I add these two numbers together. I get my, this is called the heat of reaction. The units are generally kilojoules or kilojoules per mole. Could we follow that? I think these are they're actually sort of fun to do. So now we're gonna do one more.
Ma'am, can you bring the sheet? But the first one.
Okay.
Back up for me again.
This one?
Yeah. Bring it up, please. Higher. Okay. Thank you.
Okay, you're welcome. Anybody else? If you go to your the PowerPoint notes, they have a couple of really good problems that one of them they've worked out for you, and one you have to try, but I think they give you the answer. Okay, I'm gonna find something for you. The notes. Hold on, where are they? Oops. Can y'all see this sheet?
Yes.
Okay. These are the notes I sent. And so I was going to go over this top one. It's already worked out for you, but I'm going to say something about it. And then tell me, I had hoped that I sent the answers to the next two. Did I email the answers to the next two? If I didn't, I will tell you the answers. Oh, hold on, somebody's. Okay, here we go. I don't want that. Okay, Hess's law, it's named after a scientist. See these delta H's? These are called your energy of reaction. They're enthalpy values. It's a thermodynamic big word for delta H. It's energy. And this is, for this first reaction, this is my goal. 1 phosphorus pentachloride, 1 phosphorus trichloride, and 1 chlorine. That's my goal. So they give me these 2 steps. I notice the PCl3 is on the left, but my goal says it needs to be on the right. So I have to flip this reaction, which I've done here. If I flip it, I have to change the sign, which I did. I look at my second reaction. I notice, PCl5 is on the right, but it needs to be on the left. I have to flip that one, which I did right here. And I change the sign. Now, I noticed before I add them up that I do have chlorine on both sides, but I don't have the same number of chlorines. I have 6 on the left and 10 on the right. So when you have something like that, you subtract from both sides the lower amount. So I'm going to subtract 6 from both sides, leaving me 4 chlorines on the right. Now I notice my reaction. It's like, 4, 4, 4, but I need 1, 1, 1. So I divide all of this by 4, even the number, and I get my answer. Could y'all follow that? Okay. I'm going to stop share so I can say something else. But so what they do in Hess's law, they give you a goal reaction, and then they give you a series of little reactions. You are basically flipping, or changing signs before canceling things. See, I already know. Can y'all tell me what I'm going to have to cancel here? The NO2, right?
Mm-hmm.
Because it's not even mentioned in that top reaction. Okay, anyway, so there's one you can try. The answer to that one, if I didn't email it, the answer to that one, now write it down or jot it down, is negative 146 kilojoules. So now you can see if you get the right answer. The answer to the carbon one, see, Felicia, I had here 683 instead of 638. But thank you and Mallory for checking my work. Okay,
You're welcome.
The answer to this one, get ready to write it down, is 197 kilojoules. Now, and one other little thing. Let's say that these numbers are given as kilojoules per mole. Sometimes they are. And you've solved your answer, and you know the overall reaction is 197 kilojoules per mole. If they wanted you to figure out just the heat of a particular reactant, you would use a mole of the coefficients to figure that out. One of the sample problems in, I don't remember the slide number, in your PowerPoints is showing you how to do that. Okay? So it's just another extra step. And if y'all need me, I don't have one worked out, but if you need me to work something like that out, I can make a note and then on Friday do that. Okay, let me say, let me stop share this. Are there any questions with Hess's law? I went over the process. For those that just came in and you didn't hear the beginning, I'm going to repeat it. This will be the last time. You have an activity that starts, I believe, at 10 o'clock today on D2L in the assignments folder. It's called assignment number 7. It's not due until, let's see, Saturday at noon. You could, you know, work one of them and then go say, you gotta take a picture of your work, but don't, you know, wait till you get them both done and then you upload it to that assignments folder. One of them is calorimetry, heat loss equal heat gain. One of them is Hess's law. Then starting on Friday after class, starting at 10 o'clock this Friday, on Chem 101, you're going to see test number 5, chapter 10 part. It's 7 questions. It starts Friday at 10 a.m. and it closes Monday at 8:30 a.m. You're timed an hour. Some of the problems are worth 3 or 4 points. Some are just worth 2 points. But it's over what I did. The concept is what I did Monday and today. Okay. Starting Friday, I'm going to start you on gas laws, which is chapter 11. So I may be sending some 2 attachments sometime before Friday, hopefully. One will be quick lecture notes on the 6 main formulas and what the little letters mean. And then one will be a practice where the word problem is, I'm giving you the formula you use to solve for it. So we're going to start gas laws on Friday, hopefully finish them up by that Wednesday. We only have 2 more weeks, guys, and I still have to cover some of chapter 12. I'm trying to have a day or 2 where we review. I will send out a practice final exam student copy for you guys, and then the one with the answers. It's so you can practice multiple choice. Are there any questions?
So are you gonna put some practice too on Kim
101?
Yeah, over chapter 10 or no?
I hadn't planned on it. I mean, do you want, I can create like a 5-question practice.
Sure.
Do y'all want me to do that?
Sure.
Yeah, if you don't mind.
Okay, so chapter 10, hold on. Okay, I will create a chapter 10 practice.
Thank you.
So no, remind me, because it's been a while since I did the practices. Those are the ones that I put what's the word? I allow immediate feedback, right? Are those
Yeah.
the ones that, okay. Okay, I will do that possibly today. Okay. Anybody else have a question? Felicia's recording this, so she's gonna, send it out like she did before to the class. And Felicia, make sure you copy me because my Tuesday, Thursday people want to see both my PO1 and my PO2s.
Okay.
Yeah. Anybody else have a question before I end the meeting? Devin, you have a question?
No, ma'am.
Okay, it just flipped up. It flipped to your name. Okay, we can do this. Just 2 more weeks. Are any of you taking chemistry 2 in the summer? Oh gosh, I'm not teaching this summer. No. If I can survive 2 weeks and then the final, that would be great. Let's see what this. Oh my gosh, there is somebody taking it. Well, best of luck. Best of luck to you. Okay, I'm going to go ahead. Felicia, you can stop the recording. Thank you very much.
Okay, you're welcome.